Hi, my name is Wallace. In today's video, we are looking at engineering science and we are looking at the topic hydraulics. This is just an introduction, the basic elementals of hydraulics. So it is not specific to any level, whether you're doing N2, N3 or N4 or even engineering physics. This is just an elemental introduction, so it might be helpful. In later videos, I will do videos regarding each level. N2, I'll do a video on N3 and also N4, and maybe in the future I'll do engineering physics regarding any hydraulics related topics. But in today's video, we're just an introduction, so it will be beneficial for anyone that is doing engineering science. So hydraulics is a study of which looks at liquids and the flow of liquids and also the transfer of energy using liquids. So that is basically hydraulics. We are looking at transfer of energy using liquids and the flow of liquids. But in today's video, we are not going to go too much into detail of the complexities of hydraulics, just the basic introductions. The more that we do the videos regarding this topic, we'll also go as deeper as we can go. So with hydraulics, the first thing that I want you to think about is liquids. We are just basically dealing with liquids, and the first liquid that can come up to our mind is water. Water is the best example or the easiest liquid that we can think of. So I would like you to be thinking about water. Every time we mention a liquid, we're thinking about water. Yes, of course, there are many different types of liquids. There are liquids like oil, we can say liquids like alcohol, it's a liquid, and so on. So, but in this case, just keep it as simple as you can and just think of water as the quickest liquid that you can think of. And then the next thing that we want to think about is the properties of liquids. The properties of liquids, I've listed a few. There are quite a few, and the basic elemental ones are the ones that we know of. And one of them is that liquids have got no shape. If you put a liquid in a square container, if you put a liquid in a container like that, it has got a square shape, this same liquid can still fit in a circular container. This liquid, when we place it in there, it will still take up the shape of the container. So liquids have got no shape, they take up the shape of the container, which means liquids can flow in any container that you put them into, which is a very good property. And also the other thing is that liquids have got a definite volume. They maintain the same volume. They retain the volume. So the volume remains the same in any container that you put it in. So if we had maybe 3 liters of water, we place it in there, it will still be 3 liters of water. As long as this container can hold the capacity of 3 liters, it will still be 3 liters. It won't change in any form. That is about having a definite volume. They still maintain the same volume. We can say maintain. Liquids maintain the same volume. The volume does not change. Well, they can change if you heat it at expansion and so on, but then we're not looking at expansion. We're looking at the same temperature here. All right, then the other thing that we can look at is that liquids are incompressible. We cannot compress. You cannot compress a liquid. A liquid will maintain its original volume. It will still be the same volume. No matter how much force, no matter how much you try to compress a liquid, it cannot be compressed. And this is a very good property that we can use, and we'll go into more details about that. All right, then the next thing that we need to familiarize ourselves with under hydraulics is what is known as Pascal's law. Pascal's law states that in a closed system, liquids transmit an externally applied pressure equally in all directions. So we have to note these words: externally applied pressure. Okay, so this pressure is externally applied, and a liquid transmits that pressure equally in all directions. So that is basically Pascal's law, and it is very important that we know this law. So the third thing that you need to understand under hydraulics is pressure. What is pressure? Pressure is the force per unit area. The force applied per unit area of a surface. That is what is called pressure. The unit for pressure is Pascal, and pressure will be calculated as the force over the area. Pressure is the force per unit area. Make sure your force is in newtons, your area is in square meters. That is how we get our pressure in Pascal. We can have a prefix kilopascal, we can have megapascal, but the unit for pressure is Pascal. Your force in newtons, your area in square meters. When it comes to area, you should know how to calculate area of a square, L times B. At least you should know area of a circle, pi r squared, or pi d squared over 4. Area of a triangle, half base times the height. And you should also know how to convert certain areas, because it is not always that you get your area in square meters. So converting also may play a big role in calculating for your pressure. So you should know how to convert from centimeter square to centimeter square. You need to know how to convert to meter square. Okay, in this case, just take the prefix value of cent, which is times 10 to the power minus 2. Then you square that, which will be times 10 to the power minus 4, and we have converted whatever is in centimeter square, it is now in meter square. If you are dealing with millimeter square, again, you just take the prefix value of milli, which is minus 3, you square that, it gives us times 10 to the power minus 6. Now this is meter square. So whatever value is in millimeter square, we can easily convert it to meter square. That is what we'll be doing when it comes to converting, because this formula that we have for pressure only accepts your area in square meters, and also your force should be in newtons. And then also, it is not always that you'll be calculating for the pressure, but you should also be able to manipulate this formula to calculate for anything. They might give you the pressure, give you the area, then ask you how much force are we dealing with. They might give us the pressure, they might give us the force, and then how much area, or even they can take it as much as far as asking you the diameter. So it goes back to the calculating of the area of any shape that we are looking at. All right. Then the next thing, our next point that we need to know is that there is pressure that we talked about, pressure that obeys Pascal's law, pressure that okay, what is this pressure that obeys Pascal's law? If we remember from the statement of Pascal's law, we said it is an externally applied pressure that is exerted equal in all directions. We are externally applying a pressure. So let's say, for example, we have a container filled with a liquid. Remember, we're dealing with hydraulics. Then we have a surface area as that. Then we apply a force on that area. That force exerts a pressure into the liquid. That pressure is equal in all directions. Okay, that pressure is equal in all directions. So this pressure that we have created by applying the force, this pressure is going to be obeying Pascal's law. Okay, that is one type of pressure. And this pressure will calculate, you take your force, you divide by the area, we get Pascal's as the force, as the pressure that is exerted in this container, in this closed system. Well, there is another pressure that we have, and that pressure is the pressure at a depth. Pressure at a depth. Okay, this pressure, we are not exerting a force, but it's just a pressure that comes about because the deeper we go into a liquid, the more pressure that we have. So with this pressure does not obey Pascal's law. This pressure is not the same throughout the system. So for example, if we have a container, this is now pressure at a depth in a container. If we have a container like that, I'm just trying to make it a bit longer. If we have a container filled with a liquid, The pressure at the surface, let me call this A, the pressure at the surface, towards the surface, is not the same as the pressure at the bottom, let me call it B, at point B. So the pressure at the top is only as a result of the liquid that is above it, and that is because of gravity pushing against the surface. So the deeper that you go into this liquid, the more the liquid that is above, if you reach at this point, the liquid that is above compared at the liquid that is at point A is not the same. So the deeper that you go, the more liquid that is above you, and that creates a pressure pushing downwards. So with this pressure is not the same in this system because we are not exerting a force. The liquid itself is creating a pressure depending on how deep you go into that liquid. So this pressure is a pressure that is at a depth, and this pressure does not obey Pascal's law because it is not the same throughout this system. It depends on how deep you go. With this pressure, we'll be calculating as the density of the liquid times the gravity, then times the height or the depth at which you go into that liquid. So the density, we'll talk about density just soon. Density of the liquid in kgs per cubic meter. The gravity, acceleration due to gravity, which they will give us in our formula page, 9,8, unless otherwise they state that you use a different value. And then the height or the depth will be in meters. So if you go down 2 meters, that will be the height that you use there. If you go down 3 meters and so on, that will be the depth that you go. So there are two different pressures. There is a pressure that obeys Pascal's law, and this pressure, you apply a force externally, you create that pressure, and that pressure obeys Pascal's law. It is the same throughout. Then there is a pressure at a depth. This pressure at a depth does not obey Pascal's law, but it only depends on how deep you go into that. If you're diving into the swimming pool, you're diving in the sea, the deeper you go, the more pressure that is above you. And this depends on two things. It depends on the density of that liquid and also the depth at which you go into that liquid. So there are two things that will affect this pressure. The pressure on this one, it also affected only by two things: the force that you apply and also the surface area. So the next thing is what is density, or how would we best understand density, because it will play a major role into us defining what pressure is and also knowing what it is. So density is basically the mass of a substance per unit volume of that substance. How much of a mass do we have if we have a unit volume of a substance, which is in cubic meters? So density defines, it is a property of a substance. Let's say, for example, if we speak about water and oil, these two substances are different in their nature. We can say water has got a higher density compared to oil because oil will always go to the surface. If you try to mix up water and oil will always be at the surface and water will always be at the bottom because water has got a higher density. So density defines the liquid or the substance that you are looking at. So density will be represented like we saw earlier. Density will be represented by that symbol. It's the mass per unit volume of a substance, and the unit for density is kgs per cubic meter. Kgs per cubic meter. And again, we should be able to manipulate this formula. Given the mass, given the volume, we should be able to get our density. Given the density, given the volume, we should be able to play around and get our mass. So with that, it is just ideal that we get to understand what density is, and it will be very easy for us to play around with that. With regards to density, in most cases, they will give us the densities of different substances on our formula information page, depending on which level you're doing. But they will give us the density of water, which is 1000 kgs per cubic meter. They'll give us the density for oil, but we know there are different kinds of oils, so they'll give us those densities. If it is not given, then we'll be given the mass and we'll be given the volume. So be able to play around with those properties, and that is how we can get the density. But with regards to water, with water, the density of water is 1000 kgs per cubic meter. Okay, that's the density of water. And when I speak about water, we are talking about pure natural water, not seawater, because if you start now comparing with seawater and so on, the density changes. But in this case, looking at natural water, just pure water, we are looking at 1000 kgs per cubic meter. And this 1000 kgs per cubic meter simply means that we have the density of water is 1000 kgs per cubic meter. And the other thing about water is that if we have 1 kg of water, this is 1 liter. Okay, these are just some easy conversions that might be helpful. 1 kg of water is 1 liter. So if they give us in kgs, we are able to translate that into liters. And then also this same 1 liter is 1000 cubic centimeters of water, which is the same as 1000 milliliters. 1000 milliliters make 1 liter. So 1000 milliliters, that is 1000 cubic centimeters, that is 1 kg. And it becomes much easier if you're dealing with the volume of water and you're trying to convert between the two. So with the mass, especially the mass, only water is 1 kg of water is that. However, with different liquids, the mass will vary. It will not always be 1 kg is 1 liter. But in terms of the volume, 1000 cubic centimeters is 1 liter. 1000 milliliters is still 1 liter, regardless of the mass. But with water, 1 kg is 1 liter. All right, that's about water, and I hope it will very much help us. Now going back to the pressure at a depth, which we said is calculated as the density times the gravity times the height. This is our density. Acceleration due to gravity 9.8, then times the height in meters, density in kgs per cubic meter. All right, the questions that you might come across, especially at N2, is that an example I would get of the question is this. The question that I have here says that a diver has equipment that can only withstand a pressure of 350 kilopascal of gauge pressure. Determine the maximum depth that this diver may dive in seawater while ensuring the protection of his or her equipment. The density of seawater is 1025 kgs per cubic meter. All right, so here's a question that we might come across. So they're saying the diver has equipment that can only withstand 350 kilopascal. The density of seawater, so remember what I said, this is seawater. The density of seawater is 1025 kgs per cubic meter. Then they are asking for how much or how deep can this diver go with this equipment, ensuring that the equipment and the person that is diving are still protected. So basically they have given us the pressure, we have the density, acceleration due to gravity is a constant, and we are basically calculating for the height. So we just manipulate this formula. Our height is equals to the pressure over density over gravity. We say 350. Now 350 is kilopascal, so it's going to be times 10 to the power 3 over the density which has been given to us, the density of seawater, not just natural water, but seawater, which is 1025, then times 9.8, and we are getting 34.85 0.43, and our answer is in meters. So the maximum depth, ensuring that this equipment still remains in perfect condition, the maximum depth that this equipment can go is 34.843 meters into seawater. So those are the basic questions that you might come across regarding pressure at a depth. Alright, so finally, after having looked at these two pressures, pressure that obeys Pascal's law, force over area, and also pressure at a depth, density times gravity times height, these two pressures we can calculate for these pressures. We obtain these pressures by calculations, and these two pressures are classified as gauge pressure. Alright, so gauge pressure basically is pressure that we obtain by calculation. Basically using these two formulas. And then also gauge pressure is pressure that we obtain by measuring. We measure that pressure and what we get is gauge pressure. So that is how we classify these two pressures. So should you come across a question that says what is meant by gauge pressure, so it's pressure that we obtain by measuring or by calculation. The other class of pressure that we have is known as atmospheric pressure. Okay, this type of pressure is the pressure that the atmosphere, our surrounding, is undergoing, the amount of pressure that the atmosphere, the air around us, is giving. And this one, it's a constant. No need to calculate for it unless otherwise they ask you, but no need to calculate for it at this point in time because they'll always give us atmospheric pressure is constant, and this is 101.3 kilopascal, unless otherwise they tell you use a different atmospheric pressure. But in most of our formula pages or information page, they give our atmospheric pressure at 101.3. Others will say 29, but 0.3 is also accepted. Kilopascal, that is the atmospheric pressure. That is the pressure around us, unless we alter or we change the pressure around us. But as it stands, we'll be using 101.3 kilopascal. Then the next pressure that we have, or another class of pressure, is what is known as the absolute. Absolute pressure is basically just the sum of your gauge pressure and your atmospheric pressure. And that gives us our absolute pressure. So if we add up the atmospheric pressure, we add the gauge pressure, then we'll get our absolute pressure, how much pressure there is. Keep in mind that when we were discussing the diver going at a pressure that can only withstand 350 kilopascal, if that diver goes to the depth of the 34 point something meters, there is also the atmosphere. So the deeper that you go into the sea, the pressure of the water will be adding on to that. But then also keep in mind that the atmosphere around is also adding to that pressure. So if we add the gauge pressure that we calculate by how deep you go, plus the atmospheric pressure, then you get your absolute pressure, your overall pressure. That is what gauge absolute pressure is. It is the overall pressure, the gauge pressure plus the atmospheric pressure. Questions that we might come across, we just have to be very careful when we read our questions in terms of are they classifying the pressure as a gauge pressure. In the previous question, this 350, if you remember, it was classified as a gauge pressure. That's why we did not bother ourselves with the atmospheric pressure. So questions, when we get these questions, you have to be very careful. Are they talking about gauge pressure? Are they talking about absolute pressure? If they are talking about absolute pressure, first take out the atmospheric pressure from the absolute pressure, then you can remain with your gauge pressure. All right, so a typical question would be somebody is filling up maybe a tire of your car. You're filling up the tire, then you have the gauge that measures the pressure in the tire. The pressure, maybe you fill up your car to be, let's say, 250 kilopascal. This is how much pressure you put into your tires of your car. So this is the pressure that goes into the tire of the car. But then what is the absolute pressure? So the pressure in the tire is 250 pascal. The absolute pressure then will be the gauge pressure plus the atmospheric pressure. If we add the gauge pressure, keep in mind this is kilopascal. Atmospheric pressure is also kilopascal, so I'm not including them there. I'll get my answer in kilopascal. So what basically we are adding is the 250 kilopascal plus the 101.3 kilopascal. We get our 351.3 kilopascal. That is our absolute pressure. So if you fill up the pressure in the tires of the car to a gauge pressure of 250, you end up with the absolute pressure of 351.3 kilopascal, because we are now also considering the pressure of the atmosphere. Alright, so in this video we're going to end here because it was just an introduction to hydraulics and also pressure, and also keeping in mind that pressure and force are not the same. Always differentiate the two. Force you measure in newtons, pressure you measure in pascal. And with hydraulics, our key point, our key law that we'll be looking at is Pascal's law, which says in a closed system, liquids exert equal pressure or uniform pressure in all directions. So once we exert a force on a liquid, that pressure is the same in all directions in that liquid. So in the next videos, we'll look at different levels and different questions that might apply to your levels, whether it's N2, N3 or N4. So we'll look at things of hydraulic press, we'll look at things of efficiency, we'll look at also losses and also work done by liquids and also work done by pressure. So those are the things that we'll be looking at in the next videos. Hopefully you found this introductory video helpful, and I look forward to posting more videos regarding hydraulics. It's gonna be a wonderful ride, and I hope you stay tuned and you keep sharing the videos as you find this information useful.